So we're now going to turn our attention to some of the infrastructure that we define in order to factor out common code that's shared between the various microservices in the QuoteServices app case study. And in particular, we're going to take a look at the structure and functionality of the BaseApplication, BaseController, and BaseService superclasses, which are then used as part of the implementation of the Handy application and Zippy application microservices. And these superclasses provide a customizable foundation for everything else, as you'll see in a moment. First, let's talk about the structure and functionality of the base application. The purpose of this is to be able to define a generic Eureka-enabled microservice creation infrastructure. And what it does is we have a base application class that will be extended by Handy application and Zippy application, so they'll inherit from this. And then they will go ahead and call its run hook method, passing in the appropriate microservice implementation class, like the Zippy application.class or the Handy application.class instance, and anything else that they want. And what this does is it goes ahead and it creates a name from the class by extracting out the name of the class, and then it creates the application with that name, so we can register it with Eureka with a well-defined name. In a more interesting way, let's turn our attention to the BaseController, because that's something that's closer to what you actually have to work with. And this approach we're showing here is going to be useful in the next programming assignments that are coming up here. So BaseController maps HTTP GET and POST request to endpoint handler methods. And we're putting them in one place so we don't have to redefine them in the different microservices. So this class, the BaseController, will also be extended by the Handy controller and the Zippy controller, but we're going to reuse all the stuff that's in here. Now, I've omitted one of the methods. Probably should have put it in there because it's a GET method, but we're just going to show the ones that are the POST methods. First thing we have here is a field that's a service field. We've done this a million times before. The difference between this approach and what we've seen before is this service is an instance of a base service. So we're going to auto-wire in the base service, which will either be the Zippy service or the Handy service when all is said and done. We then have a couple of methods here, both of which are going to end up doing posts. So you're going to see that these methods will receive the incoming HTTP post requests sent by the client, and then they'll forward them to the corresponding service methods that are part of the Handy or Zippy service, get the results, and then send them back to the client. Now, there's a couple of interesting things to note here. First of all, you'll note that we have post mappings instead of get mappings. And the reason for that is that we're sending the requests over as lists. And because we're going to use a really cool automated proxy generation mechanism called retrofit, we need to have these passed as post request bodies. So these are both post endpoints, and request body basically says that you want to be able to take the request that's being sent by the client and stick it into the body of the HTTP request, the post request. And by putting the request body annotation here, that means that instructs Spring to fetch or pull out from the body of the request the list of queries rather than trying to expect to extract it from the URL itself. So request param will get the results out of the URL. Request body will get it out of the body of the message. And this is what's expected typically when you pass around aggregate structures like lists or maps or so on with retrofit, which we'll talk about here in a second. Note, by the way, we have generic parameters here of type T, and that's because it allows us to be able to use this both for classic Java types like list of, quote, as well as reactive types like flux of, quote, or observable of, quote. We'll talk about reactive types in an upcoming lesson not too far from now. So let's now talk about the structure and functionality of the base service. So you'll see here we have the base service. This is the superclass that will be extended by the Zippy service and the Handy service. We then define these methods, which are defined as abstract, and then those are intended to be overridden and implemented in the subclasses. So you'll see Zippy service and Handy service will override and implement these methods. Once again, note how we have these generic parameters that are used to define the return types. And that way, again, we can plug in either classic Java types like lists of quotes, or reactive types like fluxes or observables of quotes. So that'll come a little bit later on in our discussion. So that's just a quick overview of the common infrastructure. And the reason we cover that now is because when we get into the specific details of each of these microservices, you'll know that they were inheriting and extending the generic capabilities we described here.